So as you know that Euclid formally defined the extreme and mean ratio in the 3rd century BC. That is a plus b divided by a is equals to a by b, as I have told you that. Okay. He had given the significance of this ratio in constructing the regular pentagon, and by the help of this you can create dodecahedron, which is unique and a platonic solid, which is written in the book of Euclid. Then in the 12th century AD, Fibonacci sequence had arrived, which changed the concept of extreme and mean ratio by showing a connection with it. And because this sequence often appears in nature, such as arrangement of seeds in a sunflower or the spirals of a pine cone, the number of petals on many flowers are in the same following the Fibonacci sequence. And therefore the enthusiast promoted the idea that the extreme and mean ratio is not a simple ratio, it is a golden ratio or the divine proportion. And likewise, slowly the extreme and mean ratio get his name, the golden ratio. The most important incident by which the extreme and mean ratio get the popularity is in the Renaissance era, in which a Luca Pacioli published a book, De Divina Proportion. That means the divine proportion, which is the term used for the extreme and mean ratio. And he was the mathematician, and the book was illustrated by the Leonardo da Vinci, and hence it gets the most popularity from this incident only, because Renaissance era is basically the revival era of classical learning, art and philosophy from ancient Greece and Rome. And the history for growing of Renaissance era is that some neighbor country of the Europe had become rich by trading and therefore can pay for the work of art and new ideas. And the second point is the church, which is in the power, but after the Black Death, which is around this era, due to this they loses the faith from the people, and therefore the church is losing his power, and the normal people minds now going to be open up. And the printing press that time also growing very fastly, due to which the old Greek and Roman books are now available to read across the Europe. And due to these things there is a boom in philosophy, art and classical learning, and therefore called as rebirth, revival of the Europe. And hence Euclid, who is an ancient Greek, so their work would be boosted by them. And the much more boosted thing is the extreme and mean ratio, which is now called as the divine proportion or golden ratio, isn't it? And then in the mid-19th century, German psychologist Adolf G. Singh tried to prove the golden section or golden ratio, a morphological beauty both in nature and art, and described it as the universal law of beauty. But as I have told you, it has really many real speciality, and we must have to appreciate that. And trying to create a baseless claims are really bad thing in mathematics, because everything in the mathematics itself has a beauty. Now let's understand some misconceptions that we have with the golden ratio. The first one is the nautical sail is claimed to be in golden proportion, which is again a baseless claim. Sometimes maybe it can approaches to nearby golden ratio, but it will not be for always. The second claim is the flanges and the metacarpal bone, which is in the ratio of golden ratio, which can sometimes approach the golden ratio, sometimes less than golden ratio, sometimes greater than golden ratio. Because in the case of Mona Lisa, I have also told that it is a real person, not an idealized image, and therefore these claims are baseless. And like that, there are many claims which are baseless. So you can pause and read if you want. So I hope now you know that why extreme and mean ratio becomes golden ratio. This is on the basis of some speciality, the real speciality, and some misleading, baseless claims. But we are maths enthusiasts, so we will try to focus on the specialities only. Moreover, the real speciality that we have talked at the starting of the video. So now let's learn some golden terms. Okay, so we have learned the golden, what is golden square, golden spiral, golden circle. So now let's learn about the golden triangle. So it is an isosceles triangle in which the ratio of the side length to the base is the golden ratio. That is extreme and mean ratio. So the next golden term is golden gnomon. It is an obtuse isosceles triangle in which the ratio of the side length to the base is the inverse of the golden ratio. And we have read this in our previous video. Now there are some more terms related to golden ratios. Okay, so you can see. So in the upcoming video, we will look the speciality of this term, the golden angle. Hopefully you get it, so don't forget to like and subscribe.